This is the guts of a dedicated Micros Digital Sprite 2 combination 9-channel CCTV multiplexer and digital video recorder that I acquired today. Part of the reason I've opened the thing up is because I need to reverse engineer the power supply, because like a lot of dedicated Micros stuff, it has 3 different supply rails. It's positive and negative 12 volts and 5 volts. Positive 5 volts, obviously. And I got this with no power supply, which explains why I got it for only 20 bucks, because otherwise these things are a lot more expensive than that. And I figured why not just show what's inside, because, you know, internet and tear down and board. So anyways, looks a lot like other CCTV multiplexers that I've dismantled in the past, of similar vintage. This one is made sometime in 2003, I think, judging by some of the board artwork, and there's a lot of 2002 and 2003 date codes, at least 2002 that I remember. Anyways, so yeah, there's a hard drive, of course, this telephone that I was looking up some of the parts numbers on this just now, some Maxtor, or Maxtor, or however you pronounce that, 160 gigabyte hard drive, and a couple of cooling fans, and the power supply connections there. These things are FETs for the supply rails, obviously, to shut the thing off if it's in some kind of or shut the hard drive off if this thing is in some kind of standby mode, or if it's not being used just for, you know, power control and whatnot. And you can tell they're FETs just because they're a TR8, which is somewhat interesting to see the silk screen delineate them as transistors, but this thing was made in Malta, so who knows, Malta the country, of course. I can't remember if they are a country or if they're a, you know, province or administrative region or something else, I don't know. And I'm an electrical engineer, not a geologist, so, or geographer or whatever. But anyways, and judging by the fact there's 3, even though there's only 2 active supply rails, these 2 for both of these, this pin, which I'm guessing is probably the gate, looks to be paralleled on both of them, so that's probably just for increased current capacity and what's likely the 5 volt rail. Then this chip, which I expect is probably some kind of processor, and that's probably the memory and stuff for it. At least I know that's probably memory. Don't know what those are. These are most likely bus drivers for the this pin header, which wasn't connected to anything in this particular unit, but that would most likely be the connection for the video processor board for the other 7 channels, because this thing is available as a 16-channel version, but this is only the 9-channel version, so there'd most likely be just a separate daughter board up here, and there wouldn't be this metal blocking plate. And there's these pair of Cypix devices and a buttload of clamps, just for ESD control, electrostatic discharge. Those are for the 2 RS-232 inputs, and this thing also is RS-485 down there. And then linear device, I'm guessing that's probably some kind of driver. We got to look those up actually, but those are just, you know, clamping diodes. Those SO8 package devices are just going to be the probably line drivers of some sort. A Xilinx part down there. Can't easily read it. Problem with a lot of these stupid laser mark parts, but that's probably XC95 something, I don't know, might have to put that in an annotation or something. That's probably more memory there. In Italy, somewhat interesting. This device, which the yellow thing is an ST Microelectronics Snap Hat lithium cell. That's just intended as a backup supply for things like RTCs, so I'm guessing that might be some kind of an RTC module or something of that nature. Just because having looked up those devices before, that's usually what they're for. There's a 3.3 volt regulator there, and another one on this big heat sink. Those are just going to be probably 3.3 volt core supply potentials for this processor. A couple of Xilinx Spartan FPGAs are probably also 3.3 volts for the FPGAs. Those are going to be doing probably a lot of the image processing and various other stuff in here. There's that 8051 right there. That is a analog devices instrumentation amplifier that's used for, at least the datasheet recommends, buffering and stuff, or is usually what it's used for. And there's diodes and transistors, probably as a signal amplification or something. 24.576 megacycle crystal. Don't know what that's being used for. Zoom out so I'm poking it. Is probably like 24WC32. That might be memory of some sort? I don't know. 78L05. Wait. Yeah, 78L05. And another thing with RG. That's another thing that a lot of these chips have. Like the potential regulators are marked RG. Whereas here they typically be marked as being just either ICs or something like a VR or something of that nature. But it's interesting to see them have their own special delineation. There's 79L05s. Wait, 78L05 and 79L05. I guess those are probably just high stability positive negative 5 volt supplies for probably just a lot of the analog processing guff in here, because down there's a pair of RCA jacks, one's audio out, one's audio in, and there's an LM324 there that's probably serving as a signal amplifier, and those two devices are most likely just, I don't know, maybe like audio processors of some sort. And various support chips, another potential regulator there. And there's a bunch more under this ribbon cable for the support board that has a lot of the alarm inputs and outputs. A whole bunch of shift registers for the various alarm inputs and outputs. And what I'm guessing, you're judging by the resistor pairs, those are probably dividers. And then there's also a whole bunch of these, but are most likely just single inline read relays or something of that nature for alarm outputs. And an idiot light that's most likely serving, just, hey, I've got power or something of that nature. There's this, don't know what that is. There's this SMSC device that's just the Ethernet management, and when I think of the isolation transformers or magnetics or something, I don't exactly know what Ethernet magnetics do. And those two devices, which are most likely just surge protection, clamping ICs, etc., and of course the Ethernet jack, and these pair of surface mount LEDs. Somewhat interesting to see them inside the thing. Ordinarily, because those are the line connected and line activity, or whatever they're specifically called, but that's basically what they indicate. Interesting to see them not outside, but whatever. Not that people will be seeing the back of this thing in operation much. Another chip down there. Haven't had a lot of luck looking up a lot of the chips, like these two Xilinx processors. I'm guessing those are probably, those video support processors, another FPGA. Couldn't find any information on any of these chips. I'm guessing those are also processors. Firmware, EPROMs. These things are video processing chips. I was able to find something on that, and then there's just a whole bunch of analog signal chains under there, one for each thing. Obviously, all this stuff would be just replicated on the non-present daughter board if it was in here. And what else is of interest? There's probably shouldn't be stabbing this with a screwdriver because I need to use it. But there's a bunch of crystals. Probably for various time bases, especially the video stuff. Problem is I haven't really last I took one of these things apart, I didn't really understand what was going on, because it was, 8 years ago, I think. Yeah, yeah, it's been a while. But yeah, so it's somewhat interesting thing, and hopefully this thing will be featuring in more videos soon. So yeah. That's a bit of a follow-up on that new multiplexer thing I got, and I think I've got all the various supply rails. It turns out that under a there was a sticker that just had the product information or whatever, serial code, whatever block crap, that was hiding this ATX connection for ATX power supply, probably for integrating into a separate system, because I've seen things like this integrated into computer housings available in the past. But pinout was not the same as it is on a typical ATX power supply connection thing. So, I mean, this fourth one, that was positive 12 volts and ground, and through a bit of probing around at various known 5 volt things like the fans that would always be powered, I found the 5 volt rails, which grounds were fairly easy to find. They're grounds, except the thing is that they've got some fairly substantial ground domain isolation, because all these things here, these kinda don't connect. Yeah, mildly annoying, but I suppose noise remediation. Like, for example, those ones that are connected to this copper port, those are not electrical master grounds. But anyways, yeah, I was able to find the 5 volts. And then with those two positive and negative 5 volt rail regulators right there, I was able to find the positive and negative 12 volt supplies, because that's what they were running off of. Obviously, because you wouldn't be running a 5 volt regulator off of a 5 volt supply unless it was a buck boost or something. And the switching regulator in 78L05 and 79L05 aren't. But yeah, it's just me and a multimeter in about 10 minutes. So, of course, obviously I'm going to double, triple, quadruple, quintuple check those, just because I don't want to gank the thing before I get a power supply. But I don't have a power supply in stock that will do this right now, so that's probably not going to happen until next year. And then we'll see if this thing works. So yeah. But anyways, such is my night. And also one other minor thing for the teardown. First off, it's a fairly thick board. It looks to be 93 mil instead of 62 mil. Another thing is that the bottom of it is covered in flux goo, and it's also fairly obviously wave soldered, because if you look at some of the unpopulated component spots right there, you can see dabs of glue where devices weren't placed, and that you tend to see with unpopulated stuff. Although it seems to be interesting is that the solder, or the pads for these, don't want to be really big. Or I don't know, I've never really done PCB design before for reflow stuff. Generally, all my PCB designs are, hack and slash, carve the bloody thing out with a Dremel, but I don't know, I'm old school like that. But yeah, it's just a bit interesting, and yeah, it's a thing. Got for cheap, knock on wood, now to see if it works. Anyways.